fully encapsulating. You'll notice the back has a little...
I know you guys are starting to get into balancing equations, kind of, maybe, sort of. Yeah. So this is an iron oxide and aluminum demonstration. So this is just an iron ball. It's FeO2. Fe is a symbol for iron. It was oxygen, right? So iron oxide. And I have another steel ball over here which is covered in aluminum. If I take both of these and I smack them together, it's going to have a lot of pressure and it's going to generate a lot of heat. And what's going to happen is you're going to see a nice spark, and everybody's going to have their safety glasses on in the front row. Especially you. And what you're going to see is the energy from the oxygen jumping off of the rust over to the aluminum and making aluminum oxide. Pretty cool. Ready? So you actually get to see some of this real time. That's all that was, is transfer of oxygen. Mentioned in dry ice, right? So right now it's sublimating into carbon dioxide gas. If we take this and put it into water, it's going to carbonate the water, just like a soda would at a soda fountain machine, but it also makes carbonic acid. Right now this pH is indicative of actually a base. So if I take some of the dry ice and I put it in here, and it's almost immediately going to start to make that carbonic acid, it's going to sublime, and it's obviously the gases are heavier than air, which is important to us because if I'm in a low-lying space, this could fill up and displace oxygen. And we'll talk about that in a minute. You're going to see this is going to start to change from pink to yellow here within a minute. So nice little color change. So this was the pH swing from a base over to an acid. Putting this water in here, hydrogen gas is going to start kicking out. You need a match? Match is easier. Sometimes the torch will actually blow the egg right off the stand. Alright, you ready? Here we go. Go. Hold on to it for a second. Okay, glasses in the front row. Everybody got it? We want to make this rich. Sometimes it'll just pop as soon as I hit the top of this, okay? But it's on fire now. She's going to slowly take her hand off and just put it out this way. And now, as that burns the hydrogen gas on the inside, is it still on fire?
I don't see it.
Some of these are hit and miss.
Yes.
They can take a minute or two.
Yeah.
So as it's burning the hydrogen gas at the top, air is coming in from the bottom, and it's changing the mixture. See the flame. Sometimes it just takes a little while for it to go. You got to be patient.
Cool, a liquid, it turns into a solid. Super cool, this solid is so rigid that it's actually going to be able to shatter.
Sometimes they just pop right in here though. Sometimes you hit it and it's not cold enough and it just bounces right back up. Are you ready? Here you go. Light the top of that. There you go. It's lit. I'm going to pull this off. Can you see the flame? It's kind of hard to see. The last one went out. Light. So you're dealing with flammable liquids when you're actually taking off your nail polish. So it has a nice yellow flame to it. But let's try another one. I call it my Harry Potter trick. Ready? Why is it green? Yeah, more. 1, 2, 3. Go. And push down hard on the top. Push too hard. There you go. And stand back because they're going to start popping. Woo! So they're going crazy now. Here, go ahead and stand back, right? So could you imagine if that was a big 55-gallon drum or a trash can this size and it had that type of reaction going on?
That used to be filled with hydrogen gas, and it when it caught fire, it just ignited and burned to the ground.
Oh, jeez. All right. Well, that's not going to work, Ryan. Okay, light it up. Light it. No, down below by you. Right, like right here. Put the flame right here. Light it up. All right. Now I'm going to drop this bubble. I'll try to hit the side of it. Oh, well, that wasn't very good. But we'll see. It's not his fault. Propane doesn't work as well as methane does, because this is a little bit rich. There you go, and the flammable range is a little bit different. Yeah, we'll try one more. This is about as good as this one gets. There you go. Get it from the side.
Notice it's sinking.
There you go. This time. Yeah, about right there. Try not to let it get too higher than that, okay? A little bit higher. There you go. And come after the ball. Light it. Light it. Yeah. Almost. That went fast, didn't it? See, those gases are going straight up. All right, go after that bubble. Oh, there you go. Let's do it again. Make a big one. Oh, the gas is still there. The gas is still there. Just because the bubble broke, the bubble is just an indicator that the gas is there. When the bubble breaks, the gas is still coming up. All right, hop on down, dude. Good job. Yeah, it's on. So now, as this burns the hydrogen off the top, and the air comes.